Welcome again, grade 12 Sikufunda Nati program. Funda Nati project which is meant for you, grade 12. Today I'll be sharing about work energy power. But basically I'm not going to go to doing calculations here, but I want to demonstrate the principle. How do you go about in doing the thing? So work energy, that is power. Just a traditional definition of work is force multiplied by distance. That is, back then when I was doing my grade 12, we used to say work is force multiplied by distance. But things now have changed. Scientists have discovered new things. They said now, no, work is a force multiplied by distance. They said today work is F delta X cos theta. Now they find that your distance should be, there should be an angle. It's not say a distance when something is on an incline. No, the angle is involved. They say work F is a change in distance multiplied by work done by an object is called force times delta H cos theta. For an argument's sake, let's say we have a box of 50 kg. I'll always refer to one pulls a box with force applied in the box. And also the friction force, let's say again, the friction force, let's say is 20 Newton. Right. Then, now, there are two forces acting. We said, where is F delta X cos theta? There are two forces acting now. There is force applied. This is force applied. That is the friction force. Now we talk of a work net, as I show you in the last video. I talk of F net, which means there are a lot of forces that involve. Now we talk of a work net. The formulas for work net are there in your question paper. They are there at the back of your question paper. Please make use of them. So work net. Now there is this force that is in this direction, which is force applied. There is this friction force is acting in the opposite direction. Then what is how to express the formula? We say a work net. Oh Jesus Christ! Work net is the change now in kinetic energy. That is the formula that is there. The work net, work done by the force, is the change in what is called the change in kinetic energy. For example, let's say you apply this box. You use 15 Newton. That's your force applied is 15 Newton. Then the box moves from rest. Moves from what? From rest. So if something is moving from rest, U is equal to 0 because it was stationary. Then you decided to pull it. Then now your U is 0. But maybe for an argument, they say calculate your V final, your VI. This is your VI, this is your VF. Now you don't know your V final, but you know your VI. Let's say, here is the scenario. You move a box, you pull the box and the both moves from rest. Then your VI is 0, your VF is, you don't know. Let's say you are calculating your VF. When an object is on the horizontal surfaces, there are two forces that are acting now. There's a force applied, there's a friction force. So your work net now is the work done by the force applied plus your work done by the friction. It's called a change in kinetic energy, which is called half mv squared minus half mu squared. I want to introduce the formula. I will not be going into details in how you calculate your problem. What is that is the force. You are applying a 15 Newton force. Then now, my work done, as I said, is F delta X cos theta. Is this 15 Newton? Delta X, let's say it moves a distance. This box moves from here to there at a distance, let's say from a distance of 10 meters. That's the distance moving this box from A to what? To B. The box was here and then the box ended up here. Let's say for that argument, move from here to here. Says that distance is 10 newtons. Is 10 meters. So my work done by the friction for my work done by the force applied will be 50 times, what is my change in distance? It's 10 meters Now, because the force, this 50 kg is in the direction of an object, so it's 50 Newton, change in x, which is 10 meters. Now cos 0 degrees, because it's in the same direction. If you pull something is in the same direction, it's cos 0, means the force applied. This box move in the same direction as the force applied. They are in the same direction. That is, we'll say cos 0 degrees. Plus, what is work done by the friction? Also, the friction force is also F. Work done by the friction is also F delta x cos theta. But in this particular case, because the friction is in the opposite direction, your friction is in the opposite direction, the force applies in that direction, friction is in the opposite direction. So now it's friction. What is the friction force? It's 20 Newton. Delta x distance times 10. But my cos now is 180, cos 180 degrees. Because, why I say cos 180? Because the friction is in the opposite direction. Cos 180 is equal to now change in kinetic energy. Change in kinetic energy. What is my half mvf, half mvi? So they say, we used to say v and u back then, but now they say final velocity vf, vi. Right, what is my final velocity? Is what I want to know. What is my mass? My mass is 50 kg. Then vf is what I don't have. But what is my vi? Is half. What is my 50? Then my I, we said, is moved from 0, so my VI is 0. So in the whole thing, you are able to calculate this VF. You know, most as a grade 12 student, you're going to add all these things, you take this thing and this, whatever you do. But the basic thing here, I just want to explain, is that if one applies the force on this particular object, and then the force applied is 50 Newton in this direction, and friction is in the opposite direction, then you can calculate now your velocity moving from your final velocity, which is your VF, then where your VI, as I said, is 0 degrees because the object moved from rest. So work net is the change in kinetic energy. Then you ask yourself how many forces that are acting on this particular object, 50 kg, there's force applied, there's a friction force, and we know that if it's on the horizontal, my force of gravity is 0, and then your normal is 0. But if it's on the horizontal orbit, my force of gravity now is going to be 0. If it's on the horizontal surface, and also my normal also is 0. So there are two forces that are equal to 0. When an object is on the horizontal surface, my force of gravity is 0, my normal is 0. So when I try to get that velocity, work net is force applied by the applied force by the friction is square half mv minus half. You know this formula. Yeah? Then what is my force applied? Is 50 times delta x cos 0. Why I say cos 0 is because this box is in the direction of a motion. Why I say cos 180? Because the friction is in the opposite direction. That's why you get a minus sign. That's how you do. Then for argument's sake, they say, show the vector diagram for this for this 50 kg object. Show the vector diagram. I'll just use a small space. Here is this my box here. Hey, this is force applied. This is the friction force. It's in opposite direction. Sorry, it's a straight line. This is the force of gravity. This is the what? The normal. Oh, sorry. If this is in this one is supposed to be less, the friction force is supposed to be less. They're not supposed to be equal, because if it's moving, less friction. This one is supposed to be more. But if it's stationary, it's not moving. That's how you do it. If it's stationary, it's not moving. If it's stationary, it's not moving. For a stationary object, stationary. How you draw it if the object is stationary? I believe that all of them supposed to be equal. All of the arrows supposed to be equal. Your force applied, your force of gravity, your friction force, your normal. If it's stationary, all these arrows are supposed to be equal. But if it's moving, it's taking a direction, the work done is in the direction of the applied force. This one is supposed to be less, because this one is the net work done on object. I think you understand what I'm trying to say, grade 12 here. Now let's take another example for an inclined surface. When an inclined surface, it's very important for an inclined surface. If an object is moving in an inclined surface, for instance, let's say now, here is the box, this 50 kg box. Here is the force applied, let's say 80 Newton. Let's say your friction, I'm just giving an example, your friction in this particular case is 30 Newton. Right. 80 Newton is the force applied, your friction. Let's say you have an angle 30 degrees. First of all, how do you draw your vector diagram? How many forces are acting there? You'll find that there's a force applied, which is 80 Newton. There is a friction force, which is 30 Newton. There is a force of gravity, which is in this direction. Then how do you draw your vector diagram? You draw, okay. Force applied, there is an object, then the friction force. You know what, when you compare this, is the same, it's parallel. Your slope is parallel to that one that is given. But your normal is always perpendicular. Your normal is perpendicular. Something which is perpendicular to the surface is work done by the normal. But now your gravity, the force of gravity is also going down there. Yeah, this thing is supposed to be that. It's going straight Fg, the force of gravity. If they ask you to draw the vector diagram showing how this 50 kg, you do like this, force applied for normal. So as I already told you that your surface should be parallel to that one that is given. Then your normal should make 90 degrees. Then your force of gravity should come down. You find that this angle is the same as that angle here, but we are not going to have time to prove that. So we have normally a normal force, they always saying in normal force Yago is always equal to 0. F normal is always equal to 0. So it means when the object is on an inclined surface, there are three forces that are acting: the force applied, friction force, and the force of what? Gravity. Let's say, for an argument's sake, this point moving from point A to the point B. And let's say, for instance, it moves from your VI now. It's let's say your VI is 12 meters per second. The box moves with a velocity of 12 meters per second. They ask you to calculate your VF. They say to calculate your VF because your VI now is 12 meters per second. So what do you do in this particular case? You look at the forces that are acting on this 50 kg. I told you, because you know your vector diagram, there's friction force, there is force of gravity, there is force applied. Then how do you do it? Then your force applied is work done by the force applied. There's a work done by the friction, work done by the gravity, which is equal to your change in kinetic energy. In fact, your work net is equal to what? Your change in kinetic energy. Yeah, this is work done by the force applied. That's the work done by friction. What is the work done by friction? Okay, fine. Something that I've missed here is the distance. Maybe the walk from A to B, it covers probably a distance of about let's say 30 meters. Let's say from moving here to there is 30 meters. So you know you are having your distance. So what is the work done by the force applied? My work done by the force applied is F delta X cos now 180 degrees. Oh, sorry, cos 0 degrees, because the box is moving in the direction of the force applied. That's why we say it's 0 degrees. Then what is the work done by the friction? Friction is F delta X cos now 180 degrees, because your friction is in the opposite direction. What is the work done by the gravity? Work done by the F gravity is plus F. Work done by the gravity is Fg delta X cos 180 degrees, which is equal to a change in kinetic energy, which is half mv I Vf squared minus half mv I squared. So a point that I want to make is that you will find that this applied force is only the one that causes 0 degrees, because the box is moving in the same direction. When friction force is acting in the opposite direction, force of gravity is pulling the box downwards. The friction force is acting. So there are two forces that are acting at an angle 180 degrees. Friction force is acting at the angle 180 degrees. The force of gravity also is acting at an angle 180 degrees. You see that my delta X is common, my delta X is common. Right, what is the force applied now? What is the force applied? My force applied now is 80 Newton, that's the 80. What is the change in distance? My change in distance is times 30 cos 0 degrees. Then plus, what is my friction force? My friction force is at, oh Jesus Christ, sorry, forget me. Let's say my friction force is 20 newtons. I forget, they're always, my friction force, they say is 20 newtons, and I say it's 20. What is my delta X? My delta X is 30. What is and cos 180? Then what is my force of gravity? You know, force of gravity, you know, most Fg is force of gravity is equal to mg. Right. There is a problem now. The force of gravity, it cannot be F delta S cos, but my force of gravity now is mg sine theta. My force of gravity, my Fg is mg sine theta. You must note, I forget one thing. My Fg must be Fg sine theta, because of this angle in 30 degrees. So my force of gravity here is mg sine theta. It's very important. Then what is my force of gravity? What is my mass? It's 50. What is my G? 9,8. Sine, what is sine theta? I believe sine theta is half times half. What is my cos 180? Maybe it's minus 1. Or cos 180 is minus 1. Yeah, cos 0. Then my half, what is my mass? My mass is 50 kg. Vf, that's what I want to know. Half. What is my mass? My mass is 50. Then what is my VI? I told you that you move from 12 meters per second times 12. So my grade 12, I just want to explain how to do the equation. I just want to explain. Calculation, you always do your equations on yourself. I won't be able in a small board like this. So my point is that when you're given a scenario like this, under this topic, work energy theorem, when the box is moving, an applied force, so there are, how many forces are acting? I said the force of gravity. Because because the box is acting in an angle, my force of gravity is mg sine theta, which is sine 30 degrees. My friction force is, what is my friction force? I said my friction force is 20 Newton. Then when you F delta X cos 180, which is 20 delta X, I said my X now, the value of my distance is 30. So you do all these things. So it's very, in physics, what is very important is to express all these formulas, is to substitute. That's what gives you the marks. Otherwise, the entire calculation constitutes 1 mark. If you put your formula, you put correct, and you put your values in a right way, then that's how you do it.